What's up, guys? For those of you who are interested in the Hyperdrive motor controller, this video is going to explain everything that you're going to need. And I'll just start by saying I'm working on a project for a three-phase motor. I've built a controller for the three-phase permanent magnet motor, and I was wondering if there was any open source code that I could program my controller with to cause my motor to run. There are a number of open source libraries and frameworks available for controlling three-phase motors, such as Motor Control Library for Arduino and the AC Motor Control Library for the Raspberry Pi. Additionally, there are several open source motor control platforms, such as the Open Motor Control OpenMC project and the Open Source Motor Control OSMC project, which provide a variety of software tools for controlling different types of motors. And I think I already went over this. Yeah. And it gives me the code. And then I pick up the conversation again, talking about the actual controller. So I asked him if there was any IGBT modules that are already configured for a three-phase inverter, which have a voltage as high as 3,500 volts, 10 amp capabilities, because that's what we want. We want high voltage transistors that are available for purchase from a manufacturer, such as perhaps Semicron. And he says, yes, there are IGBT modules that are already configured for three-phase inverter that have a voltage as high as 3,500 volt and current capabilities of 10 amps or higher. One example is the Semicron Skip, and he gives me these different types, different modules. And I ask him about the switching frequency rate, and he gives me the rates. And I ask about the price, and he gives me the price, $30 to $50 each, $50 to $100 each. And I ask what would be the necessary components required to construct a 1200 volt DC power supply capable of powering this inverter. And he tells me there's an input rectifier and all this other stuff, DC link capacitor, DC converter, inverter, which that's the three-phase inverter. IGBT modules, the filter, the thermal management and protective devices, and the control and monitoring, i.e. the control board. And additionally, specific design components we use depend on the requirements and applications such as power rating, blah, 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 blah. And I thank him, and I tell him that all the components that he just described are the same components which are found in electric vehicle control modules, are they not? Including the three-phase inverter and the microcontroller board, as well as all contained in a control module for electric vehicles. Is that not correct? And could I purchase a used one online? And he says, yes, I'm correct. All the components mentioned. So we're talking high voltage, okay? High frequency controllers that are intended for EVs. And he says, yeah, you can buy them online. And so I ask, is there a way to access the control side of these systems and alter the parameters for a different type of motor? He says it is possible to access the control side of EV control modules and alter the parameters for a different type of motor. The control side of the EV control module typically includes a microcontroller or digital signal processor, DSP, that is used to control and monitor the performance of the power electronic devices. These devices have a firmware that can be programmed and reprogrammed to match the requirements of the specific motor and application. Blah, 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 disclaimer. And before attempting, be a professional. And so I say, cool, dude. So I could potentially use the open source codes you have provided to reprogram these controllers to suit my specific applications, correct? Yes, it is possible to use open source codes and reprogram EV control modules to suit your specific application. And he talks about the Open Motor Control project and use these codes and platforms to do it with. And these libraries can provide a good starting point for programming the microcontroller or DSP in the EV control module. But you will likely need to do some additional work to adapt them to your specific motor and application, i.e. sensors. And it gives some other good information. So, yeah, you can do that. And the point would be that you can get an affordable high-voltage controller that is set up to be powered by, I believe it's 350 volts DC. And then it steps it up to 1200 volts from there. It has a boost converter. That's what that boost converter component is. It's a DC to DC converter, and it boosts it up to 1200 volts. And when it does that, it makes it way more efficient. But its main input power is like 350 volts DC. So, yeah, you would just need a 350 volt DC power supply. And you can do that by creating a rectifier from wall power. Convert AC to DC, and then and then step it up from there. Because if you convert AC to DC, that's 120 to like 60, or no, I think it's 120 volt DC is what it converts it to. 100 volt DC, or maybe it doubles it. It either doubles it or it's half. I think it doubles it. It's like 240 volts DC by rectifying AC to DC, rectifying to 240 volts, and then you can do a voltage multiplier, and you can multiply that voltage from 120 up to 240, or from 240 up to 480, and then you could even limit it down even further. You could regulate it down from there to 350. Feed that thing 350 volts DC from wall power. Convert your AC to DC and feed it with 350 volts DC, and then let it boost it up to 1200 volts. It's the most efficient motor controllers on the market, or motors on the market. Permanent magnet DC motors. Permanent magnet brushless 3-phase motors, I should say. That's what they are. Anyways, just thought I'd share that with you. And, this is just I thought there was more to this, but it's not showing up. Huh. Anyways,